So quick reminder, I do have the Discord lecture channel open. I'm still doing this every lecture. So if you have questions, you can post them there, or just do it the old-fashioned way, raise your hand. There are usually TAs who are in lecture who are answering questions on there. We have 3 TAs right here answering questions during lecture as well. So even if I'm not watching chat the entire time and I'm not seeing everything that's going on in there, the TAs are being pretty good about being in there and answering questions and having a dialogue with you. So feel free to use that. But with that, let's get into today's content. So we've seen lecture tasks 1, 2, and 3 of the project so far. And you can do the functionality of these, but the big part of all these is testing. You have to test all the functionality, test all the features of each task, and then write the functionality also after you have those tests. But we haven't learned about testing yet, so let's remedy that. Let's learn about unit testing, a big part of this course. Every task, almost every task I should say, is going to have unit testing requirements for it. So I know you can't read that, I just want to have the doc open. And let's get into some unit testing. Yeah, only on the first week and a half or something, I have slides, the word slides next to the slides, but that icon is always the slides on the course website. So if you want the slides for today, it's just it's just the icon. The icon is the slides. I just do this for the first few to mark it, to let you know, hey, this is where the slides are going to be. But from here on out, it's click on the slide icon. Yeah, Opera GX for the win. So let's talk about unit testing. Like I just said, your lecture task for today, no new tasks. We're not moving on to number 4 yet. But adding testing to your first 3 lecture tasks that you have, which, just a reminder, the lecture tasks, everything to do with the homework, we're going to check that at the LO1 checkpoint. But I strongly recommend that you, at the very least, try each lecture task after the lecture that is presented, at least before the next lecture. If you come into this lecture without even having attempted lecture tasks 1, 2, and 3 and looking at them and getting them in your mind, today's lecture content might not make much sense. Same with Wednesday's lecture content. If you didn't even attempt lecture task 2 before going into Wednesday's lecture where I'm introducing lecture task 3, it's just really hard to keep up. It's really easy to fall behind if you're not doing that. At least attempt each lecture task. And what I'd recommend and what I would do is attempt the lecture test during lecture. As long as you're keeping up with what's going on in lecture, sit there on your laptop and start banging out some code and see if you can get the lecture test done. That was the original intent. That's why they're called lecture tasks. We used to call them lecture questions and have them due at the end of lecture, which, as you can imagine, was really stressful, so I backed out of that idea. But that is still the intent, that here's the lecture content to complete this task. This task will reinforce the lecture material. You should be doing them hand in hand. We have a lecture, work on the lecture task right away while the lecture is fresh in your memory. Or else you're just wasting time if you have to go back, remember the lecture to work on the task. You have a question? It's what was the part right before Scala equivalent of that? There is an equivalent. I don't know off the top of my head, but there are a lot of ways, because you do have that header line. So the question is, how are we handling that header line when we're reading that CSV file? We have a header line that just says what all the columns are. That header line will be there in AutoLab, so you can't just, what I've seen students do in the past, delete that line and then go for it. So you do have to have a way to ignore that line somehow. There is a method for what you're saying to read one line. I don't remember off the top of my head what it is, unfortunately. One trick that I like to do is look for that exact line and then skip over it. So even in my solution, I have if the line I'm reading looks like the header line, then don't do anything, don't process it. But if it looks like a city line, then process it. One kind of brute force way to do this is if line equal the entire header line, don't do anything with it. So that's one way. If that's not your style, if that's not your flavor of doing it, then read that one line up until the first new line character and then start processing the data. But again, I'm not remembering off the top of my head because I haven't used that one in a while. All right, so you write code. We write a lot of code. How do you know your code's correct? Pretty fundamental question. If I go up to, if there's no AutoLab, like right now and in 1.15, you would just submit to UB Infinite, you submit to AutoLab. If AutoLab or whatever automated grading software we wrote for you says it's good, then it's good, right? It's, that's going to tell you. But if I take that away, if I say no AutoLab for you, and you show me code that you've written, and I say, how do you know that's right? How are you actually going to answer? How are you going to know that your code's right? And by the way, this is where we have to get you. We have to win you off AutoLab. Each semester you go through, you'll get less and less feedback from our automated grading system. I cut back quite a bit this semester, and then next semester in 220, 250, you get a lot less feedback than what you're used to in 115. By the time you graduate, we have to have you able to write software with no feedback at all because that's what you do on the job. That's what people are going to pay you a lot of money to do. They're not going to write an automated grading system for you, out there in the real world. It's just not practical. So we do have to win you off of that before you graduate. So how are you going to do that? How are you going to be sure that your code is correct, or at least reasonably assured that your code is correct without some definitive answer for you in the form of AutoLab? So let's go through an example and see how to do this. So recall this example from last week. I'm just checking whether an input number is large, medium, or small. Not the most interesting method, but it gets a lot of our points across about what we're learning and getting us used to Scala. So if the input is larger than 60, or greater than or equal to 60, we want to return the string large. If it's less than 30, we want to output the string small. And if it's anything else greater than or equal to 30 but less than 60, then we want to return the string medium. If it was a lecture question, I would word it something like that and say write a method that takes a double, returns a string. If the input's greater than or equal to 60, returns the string large, et cetera, et cetera. That would be the lecture question. And this would be the solution to that question, or a solution to that question. But how do we know it's right? How do we know this method satisfies that question of having these boundaries of 30 and 60? Well, for right now and for 115, hopefully you were doing this in 115. It's a struggle to get the entire class to do this in 115. But hopefully you're writing a main method, you're calling the method that you're testing, printing the results to the screen, looking at the screen, what's printed out, and verifying that it's what you expect. You would write a main method like this, and you would expect this to print out large, medium, small. You're going to run your program, and if it prints out large, medium, small, you're feeling good about your code. This is really good for 115 testing. We don't expect you to do much more than this in 115, but man, it's always frustrating in 115 when somebody comes to office hours and doesn't even run their own code, doesn't call their main method. So it's a struggle to get you to that point. Hopefully you're all in 116. Hopefully you've all made it to this point where you're writing a main method, somewhere calling your functions and making sure that they output the right output on some specific hard-coded inputs that you've decided. But what happens when your project gets large? This course is all about what do we do when our code bases and our projects get very large? How are we going to manage and maintain all of this code? So what happens when we have thousands of files, hundreds of classes, directories and packages all over the place, and just this huge code base with hundreds of thousands of lines of code? What are we going to do then? If you make a change to this code base, a change in a large code base like that could have rippling effects, like everywhere else in your code. If you change a method, everywhere else in your code where that method is used, and any methods that use those methods, everything could change with one little change in your program. So how are you going to make a change and verify that everything is still working the way it's supposed to? Well, I'll tell you one thing, I'm not going to run all my main methods and make sure they still output the right things and manually verify everything. It's just impractical when we have a lot of code. and we have a lot of stuff to test. You don't even want to do that just for PaleBlue.project. Think of getting to the last objective. You got your 6 lecture tasks, you got your 2 application objectives, you make a change late in the project to a method that you're calling in other tasks. You don't want to run all those and look at all the output and verify that. That's just slow. We don't like slow, we like fast, we like automation, and that's what we're going to do. We're going to introduce unit testing, which is going to give us a way to automate the testing, and in practice, these will run automatically whenever the code is changed. Whenever somebody changes the code, the tests are ran. If the tests break, the system yells at you and says, hey, you just pushed code that broke stuff. Fix it. In this class, you're going to write your tests and then run them, and it's going to tell you if all your tests passed or not. And we're going to run lots of checks. Like the example that we saw would have 3 tests in it in what we call a test suite. Those tests, or test cases, I'll sometimes refer them to, 3 test cases. On this input 70, did it return large? On this input 50, did it return medium? And on this input, I think it was 30, does it return small? Those are 3 test cases. If all of the tests and test cases pass, meaning you got the correct output on all the inputs, then that test suite will pass. If any one of them did not pass, if any one of them, your code did not return the correct value, then that whole test fails. So it's an all or nothing. You have to get every single one of the tests. If they all pass, then your code is good. If even one of them fails, that code's bad and it fails the test. So let's jump right into it and see what a unit test in Scala looks like. So let's take a look at this one. We'll look at this for a few slides. I know it's a lot of code all at once, but we're going to break this apart and take a look at each piece individually. So this is our first unit test for Scala, our first test suite, which is going to test the method that we saw on a few slides ago, that large, medium, small testing. For this, we're going to need Maven. You should all have that set up after this week's lab. I think there's at least 1 or 2 more labs tonight. So after this week's lab, everybody should have Maven set up with all the versions. If you can run that GUI 2D, it means Maven has already been ran, and you have all the dependencies that you need. One of those dependencies is Scala test, which is an external library. It's not included with Scala that we have to download and link to our project. Maven does all this for us. If you ran that GUI, Maven has been ran. IntelliJ is usually pretty good about doing this automatically when you clone the repo. It'll run Maven for you. If it doesn't, I guess post on PS or come to office hours. If it doesn't, we can definitely go through that, or ask your TAs in lab. We'd be happy to help out. Since IntelliJ has been, I used to demo it, but since IntelliJ has been so good about running Maven automatically, I don't demo it anymore. But I can if it becomes a big problem. So that gives us this library Scala test, which does need to be imported. We need to import that in our code. So we're going to say import org.scalatest._, where the underscore is Scala's wildcard. This is like star in Python. Import star from some library. This is the same thing. This is saying give me all of the classes and objects in this Scala test package. One of the classes that was imported in this line is a class called FunSuite, which we're going to inherit. Those are words that I don't expect you to know at this point, class and inherit. We're going to talk all about that in LO2 until you're sick of hearing about those terms, classes, inheritance, polymorphism. There's all kinds of fun topics. That's all for LO2. For now, I'll give a very quick description for those of you interested. FunSuite is a class with all kinds of functionality, all kinds of variables and methods. We're going to create a new class, which is a way of creating objects called test compute size in this case, but you should name these whatever they're called in the homework document, like lecture test 1, lecture test 2, that's where that would go. And for PaleBlue, that's all set up for you so you can have examples of the structure of these things to make sure that we're on the same page with our verbiage, with our vocabulary. So I'm going to create a class, extend FunSuite, meaning this class that I'm writing is going to get all of the functionality of FunSuite. So everything that FunSuite can do, our thing can do, our class can do. All this has to be here. And I don't have a slide for it, but we're going to import any of our code that we're testing. We're going to also have to have import statements for those because we're in a different package. We're always going to be in the tests package for our unit testing. Once we have that set up, we're going to create our test. We're going to call the test function, which we inherited from the FunSuite class. FunSuite, I forgot to mention, FunSuite short for function. I think they are fun, but it doesn't mean it's a fun suite. It's a function suite for testing functions. So a lot of what we do is write a method and then test it using a function suite. So once we have that, we're going to call the test function. It takes a string, which is a human readable name for your tests. I don't enforce what your tests need to be named. They're whatever you want to call them. This one, but ideally they should be descriptive of what they're testing. Doubles are checked for size in each category. Some description that says, what is this test actually testing? There's no main method. There is a main method that's inherited by FunSuite. FunSuite is handling how this is ran, how this is executed. And then any tests that you create are going to be executed when the FunSuite is ran. So this is the whole structure that we need. And then finally, writing the test itself. This is going to, at some point, involve calling the function or method, calling the method that you're testing, and verifying that it gave the right output on specific inputs. We're going to do that using assert calls, assert statements. We're going to use assert statements, which take a Boolean expression, and we're going to expect that that Boolean expression is true. So we're going to use all the tools in our programming toolboxes to write some Boolean expression, such that if that Boolean expression is true, if it evaluates to true, then that test passes. If the Boolean expression evaluates to false, that test fails. So here, I want to call my compute size method, which is in the conditional object. So I'm importing my code. I'm going to the conditional object and saying call your compute size method on the input large double, which is 70, and check if that equals large. So this is my test case. I'm going to call the method that I wrote with the input 70 and make sure that it outputs large. I'm going to do that with an equal, just check for equality at this point. And if this method call returns the string large, this Boolean expression is going to be true, and this test case passes. If all three of these test cases pass, then the test suite itself passes, or rather the test passes and the test suite. So we have, I should get the terminology consistent, test case, test case, test case, test, test suite. You can have multiple tests in your test suite. You just have this code and do the same thing right below it outside in a separate block. You have multiple tests that helps you organize your tests. If you're testing different things, you can give your tests different names and know which one failed. This assert statement takes an optional second argument. If you don't want to use this one, I encourage it, but if you don't want to use it, everything's still going to work here and you can still get through the assignments. But the second parameter, or the second argument, if provided, is going to be your hint text, which is going to be displayed in the testing when your test is ran, if it fails anyway, when that test case fails. So if this test case fails, if you want some extra information about what failed, put that as the second argument. So here, if this test fails, I want to know what the input was. I'm going to print out large double, and I could add more verbiage here. It wouldn't really fit on the slide conveniently though. I could add more verbiage like failed on input large double. And then I can know what exactly went wrong. Instead of just knowing that the test failed, I get some extra information, whatever you want to print to the screen. the state of certain variables, what was actually outputted, things like that. And that's your first test suite, your first unit testing in Scala. Are there any questions? Yo.
So for the electric task, do we just put testing in the electric other three tasks?
Yeah, for the lecture test, to add testing, there's a test package. So I created the structure in the Pale Blue Dot project. I won't do that for all the projects, but just to give you, show you how it goes. In the test package, there are test suites already set up for lecture task 1, lecture task 2, lecture task 3, up to 6, and then the application objectives. You want to go into those and then add your actual tests for each lecture task in the corresponding test suite.
Do we plug in like the numbers and like the cities and stuff for the test itself?
Yeah, for the test itself, like for testing lecture task 2, you would call your method on some country name, and then assert that it outputted the correct country code with the correct capitalization. So you would pick countries out of the file. You can scroll through the file, like grab, like 5 or 6 countries and country codes. Use those as inputs. The inputs as mixed capitalization. Use, all uppercase, all lowercase, different combinations and things like that, and make sure you always get the right country code back. But you would get specific examples here. Like here I have specific examples. 70, that should return large. 50, that would return medium. Japan should return JP. Things like that. So you need specific things. And when you get to lecture task 3, go find a country code and region. And make sure, go through the file, check all the cities and the populations of those cities, create a map with all that information, and then make sure that you have all that information returned. All right, let's see this in, that's the wrong desktop. All right, let's see this in IntelliJ. So this is the same code that we've seen, that we just saw in the slides. When I run this test, which you can do, the arrows, you can right-click, all kinds of different ways to run this. But when you run the test, you're going to get some results. What happened with the test? Here, my test passed. My code is fine. My code does everything right. We could verify that manually. But here with the test, this is the output that you're going to see. You're going to see this glorious green check mark. As a developer, we always feel good when we see that, when our unit tests are passing. You'll experience it for sure, but it's a good feeling. So if we go into this compute size method, and I make a change here, maybe I accidentally had an uppercase L here for large. I'm going to rerun my tests, and I want my tests to be able to find mistakes like this. My test suite should be like, that code's wrong, something's wrong with that. And here we get that. The test failed. And I can use this interface to get some information about what went wrong here. So if I take a look at this, I can see my hint text. Actually, this is the test suite helping me out quite a bit. Gives me a lot of information here. And somewhere in here should be my hint text. Oh, right here. My hint text. So this is showing me, once you learn how to read this at least, pretty clearly that, hey, this lowercase l, this uppercase L should have been a lowercase l. The test suite, I'm surprised it actually shows that much. That's a lot of information. So you get a lot of information here to be able to adjust your code and get that correct. So once we get our code correct, we'll get back to our pass and tests. Oh, I know what happened earlier. Any questions on this? Well, while we're in IntelliJ, I didn't mean to go out of IntelliJ so quick. So once you write your test suite, you'll have your test suite like lecture task 1. Write it, right-click, and go to run. Or you can run each individual test. Like I have multiple, let me get rid of this. Like I have multiple tests here, like I was saying. Tests, you can run an individual test, or you can run the entire test suite up here which right-clicking on this and running, that'll run the entire test suite. Be careful using this button up here. This button will always run the last thing that you ran. So if you're working on lecture task 1, you get the testing done, you're running it, you get your green check mark, everything's good, then you move on to lecture task 2. When you use this button, it's still going to be running lecture task 1. So use that with caution. It's always a frustrating experience for a student who comes to office hours with that problem. Save yourself some time and frustration. I would get in the habit of right-clicking over here and running, or verifying right here. This is going to tell you what's about to be ran if you use this button. Just a heads up on that. Don't get too used to that button when you're running a lot of different files. Okay, so we ran this test, it passed, we're feeling good. But this is a question that will be recurring throughout the semester. Usually AutoLab is going to tell you that you don't have enough testing, but is this enough testing? Are we feeling good about this test? Meaning that if we have this test and we can't even see the code that's being tested, if this test suite passes, are we confident that that code is absolutely correct? Because I'm not feeling so good about this one. So here's an example of the correct solution. Here's a reminder of the correct solution. Our boundaries are 60 and 30. And here's another implementation of this code with boundaries of 65 and 20. This is wrong. This is an incorrect solution. But when we run our test suite on this code, that test suite's going to be like, hey, everything's good. We're happy here. Because we didn't test close to the boundaries to catch these kinds of errors. This is always a big question with testing. How much testing is enough testing? And for each lecture task and each application objective and each method that you write, even outside of the class, they all present their own unique challenges. And this is where it takes some creativity, it takes some thinking of what could possibly go wrong with this method that I need to test. For this method, I want to test those boundaries. I want to make sure those boundaries are tight. I want to make sure that as soon as I cross that boundary, the method is outputting a different answer. I want to make sure, I don't want to just test one in the middle of each boundary and check, like we were doing before, just one large, one medium, and one small. I want to test those boundaries pretty hard to make sure that this solution fails when I run my test. I want to run my test on this thing, and I want my test to say that code is wrong, that is an incorrect implementation of that code. So let's tighten this up a bit. Let's write some more testing. I'm going to add more test cases, one more test case, and change the other ones, and get right up on those boundaries and check those boundaries. So now I have the smallest possible large, close to the largest possible medium, the smallest possible medium, and close to the largest possible small. Then I'm going to test all of those and make sure that all those pass. Now when we run this test suite, that incorrect solution we just saw, it's going to say that code is no good. Fix your code. Is this enough testing? This is a bit tougher question to answer. Is this enough testing? If you had this testing and you said, I'm good on testing, if any code passes this test, I'm feeling good that that code's correct. It's debatable. You know, this one's pretty good. You could reasonably stop here and say, we're good with testing. If anything passes this, we're feeling okay about it. Now, we can certainly come up with incorrect solutions that this test will pass, but it's pretty good. You know, nobody's going to get mad at you if you have this testing. Maybe, I don't know, maybe I would get mad at you. But it's not terrible. But we can go further. So let's go further. We have automated testing. We can throw all kinds of test cases at this. We can have hundreds of test cases. It doesn't take us too much time to write them, and they're automated, so every time we run them, it's just, the computer doing the work after that. So let's just load this thing up with test cases, and let's use some data structures. Let's remember some of that data structure stuff that we learned on Wednesday, and take advantage of that. So instead of naming each variable, like we're doing here, We'll get bogged down real quick if we start naming every single test case, having these new names for every single one. We're going to end up with large double 1, large double 2, large double 3. Sometimes that's the best thing to do, but in this case, we have a pretty good solution. We're just going to use a list and have 3 lists which store the inputs for each of our 3 outputs. So I'm going to create a list of all the inputs that I feel like testing that should return large, all of the inputs that should return medium, and all of the inputs that should return small. And then I'll run all of these and check, did all of the large doubles return large, etc. And now if I want to add more test cases, I just go to the expected output. I want to add more larges. I'm just going to go to that list and pop in a few more inputs. It's super easy to add more test cases this way if we organize our code and think about the structure of our code a little bit. So here, we can test all kinds of inputs. I'm going to test negative numbers. We didn't really define what should be returned, but we're going to say that they should return small. I'm going to test a very large value, make sure that it still returns large, a bunch of mediums, and still, again, getting right up next to those boundaries. We could even add more 9s here and get even closer to the boundaries. There's some more, we can always go further. That's why it's always a tough question, when do we stop? Like you could look at this and say, well, we should keep going. And you can look at this and be like, man, that's overkill already. It just depends, I don't know, it depends on a lot of factors. And there can be a lot of debate around that. How much testing is enough? Yeah.
So like, with the incorrect solution, when you change it to 65 and 20, why would that be called incorrect? Like, why is it just us changing boundaries?
So assuming that the original problem statement had the boundaries at 30 and 60, and you're asked to write a method with the boundaries of 30 and 60. So under that assumption, once we change away from 30 and 60, like I'm not saying we agreed that small is now going to be less than 20. I'm saying small is still less than 30, but we changed the code to not comply with the question that was being asked. Like if that was a lecture task, the lecture task would state the boundaries, and then the code has to comply to that. I actually do want to talk about this. The second parameter gets more helpful in these examples. So once you have your test inputs in data structures, it's harder to tell, because when the test suite fails, it'll tell you which line failed. It'll say this line failed on this line. And here, since we're using equal, we get all that nice output from the library. But depending on how we're testing, we might not always get that output. So the hint text, the second argument, is going to be the hint text, which is displayed to us if the test fails. So here, I want to know if this line failed, I want to know on exactly which input we failed on. What large double, which one was it that my test failed, or that my code failed on, so I can go to my code and start my debug process. Okay, I passed on these ones, but once I got to 1,000, it failed. I want that information. I want to know that. So I can go to my code and look for a bug that is failing on large values, but doing okay when it's close to the boundary, things like that. So the hint text, it's completely up to you what you put for the hint text, but I do recommend it. If you don't have hint text and there's obvious hint text that would have helped you and you're asking me or a TA in office hours, you probably know what we're going to say. Get some better hint text, and we're probably going to say run the debugger too, because we love saying that. The debugger, by the way, will save you countless hours of time. It's when I first learned the debugger, and everybody has the same account of this. When we first learned the debugger, it's like, why have I not always been using this? It's an important tool. Learn how to do it right here in your second semester of computer science, and use that throughout your career. It's so valuable to save so many times. It can save you all-nighters. It can really maintain your sanity if you learn to use that early and use it often. $150, $240 every time. I'm going to be doing that for weeks. I don't know if I might be doing it the last week of lecture still. $240. So I promised I would talk about testing doubles again when we talked about unit testing. I'm making good on that promise. Doubles are imprecise. They are truncated We don't always have the exact value stored in a double that we want to have stored. The example we showed was 0.1 cannot be stored exactly in a double in 64 binary bits. It can't be done. Shouldn't say it can't, but in the double format, the IEEE double format, it can't be done. It can't be represented exactly. So there has to be some rounding, there has to be some truncation, which leads to truncation errors. This is something we have to be very aware of, especially now that we're writing unit tests. When we write a unit test that's testing a double, which I think the first one is learning objective or lecture task 4. Because the first 3, I just want you used to the structure of unit tests. But when we get to, at the very least 5, oh man, I don't remember off the top of my head. I think 4, I'm testing your list ordering. But when you're testing doubles, never, ever, ever use equal, equal. If you're using equal, equal, so say this is your test, you're testing some method and using equal, equal on doubles, you could have the correct output, but fail your test due to the truncation error. So we don't want to use equal, equal. Never compare doubles with equal, equal. Never, ever, ever. Don't do it. It's just asking for trouble. And they are very hard bugs to debug, find and debug, if you're not actively thinking about it. Instead, we're going to choose some very small value, small enough that it's not going to affect the logic of our problem, but not so small that it's going to include truncation errors. So I'd say this, this is fine, but maybe a little small. I at least go out to 2 decimal places, depending on the application. If I'm expecting the value, if my expected value is 0.002, for example, obviously I need some more zeros. I need this kind of epsilon. But some very small value, and then make sure the difference between the 2 doubles is less than that very small double. So we're going to say that these 2 doubles are equal within truncation errors. So if they're close enough, and again, epsilon is going to change based on your application. If you're measuring like atomic distances, for example, in meters, you're going to have a very, very small epsilon. It depends on the application. But whatever epsilon makes sense for your application, that's going to take care of truncation errors but not mess with the logic of your problem. That's what you want to compare it to. And if the difference between those values is less than that epsilon, we're going to call it good and return true. That less than will resolve to true, and we're going to be good. We're checking the difference by subtracting. So C is going to be something very close to 0.3. We don't know if it's slightly above or slightly below 0.3. But if we subtract, we'll get the difference, and then take the absolute value of that difference. Whether it was slightly above or slightly below, we're going to get some very small value. Check if that's less than epsilon. And if it is, we're going to call it good. I don't want to see anybody comparing doubles with equal, equal. When you submit to Autolab, when you write your first unit tests and you start submitting to Autolab, I want to talk a little bit about what the Autolab output is telling you. There is a pinned post on Piazza that gives some more information, but I want to give you like the high-level overview of what's going on when you submit your code. This causes a lot of confusion each semester, so I want to make sure we're all understanding what the Autolab output is saying. When you submit your tests are going to be ran multiple times. They're going to be ran once against your own code, your own solution, and which better pass because hopefully you ran your own tests before you submitted. There are some weird cases where it does go well on your laptop and not on Autolab, but in most cases that should be fine. Run against your own code, make sure that you ran your tests against your own code and they pass. Then I'm going to run your tests against my solution. So I have my solution on Autolab, and I'm going to take your test suite and my solution and run your test suite against my solution. And again, that should pass. That one's a little more iffy. If your unit tests are complying with the problem statements, then that should certainly pass. There should be no problems running against the correct solution. If all of your tests, unless you're checking something that is not what you're supposed to be checking. Like for that example, if you had the boundaries off, if you thought the boundary was 70 and 25, maybe you have some tests that are going to fail my correct solution. So against your solution, against a correct solution, and then against a variety of incorrect solutions. So I also have incorrect solutions on Autolab. I'm going to take your test suite and I'm going to run it against each one of my incorrect solutions. This is code that's intentionally wrong, and intentionally wrong in different ways, in a variety of different ways. And if your tests are accurate, if your tests are thorough, if they're good enough, whatever that means for, that's a big question in this whole field, this whole discipline. If your tests are good enough, though, they should fail all of my incorrect solutions. They should pass your solution, pass my solution, and fail all of the incorrect solutions. So your testing needs to be thorough enough, at the very least, at the bare minimum, to determine that all of my incorrect solutions are in fact incorrect. Now, if it does, that doesn't necessarily mean your tests are perfect and that they're good to go. That means they're good. But it doesn't necessarily mean they're complete, but it does mean that you're past the testing portion of the lecture test. And then once you get all of your testing done, then you'll see more output on my tests. I have my own test suite that I'm going to run against your code to verify the functionality. And it's possible to have all of your testing check out in Autolab, and then also fail one of my tests, and then have some more work to do on the functionality. So if you get all this, it doesn't necessarily mean your tests are complete, but it does mean they're looking pretty good. There's a certain standard that you've crossed, that you have pretty good testing. So here's an old lecture test, back when I called them lecture questions, that I used to run. Computing the shipping cost of a package. So this takes a double as an input, and outputs the double as an input, which is how much the package weighs, which is intentionally unitless, and outputs $5 for shipping is a flat rate, and then is a quarter for every pound. Oh, I do say pounds, don't I? Sorry, it's not unitless. And then a quarter for each pound over 30. So if it's 30 pounds or less, it's going to cost $5 to ship. If it's 31 pounds, it's going to cost $5 and a quarter to ship. If it's 34 pounds, it's going to cost $6 to ship, etc. And you can have fractions as inputs. It can be 30.5 pounds, and it should be 5 and 12 cents and half a cent. How come I'm struggling with how to say that? But and then you would write tests for this method. With this, when this was a lecture question, you would submit to Autolab, you'd have your code, you'd have your tests and everything, and it would be ran against your code, a correct solution, and then these were my 5 incorrect solutions for that function. For each incorrect solution, I give it some cute cryptic name which gives you a hint of what's going on with my incorrect solution. So, for example, this one, rounding weight. I have mostly the correct solution. If it's less than 3 pounds, it's $5. Otherwise, take the flat rate of $5 plus a quarter per pound, except first I'm calling math.round on the weight. So if it's 30.1 pounds, I'm going to get the wrong answer. What this is doing, what that specific one is doing, is making sure that at least one of your tests have a non-whole number as the weight. Some weight that's over 30 with some fraction. If you don't have that in your test suite, you're not really testing everything. You don't have a thorough test suite for sure there. If your inputs are doubles, you better not be testing with only integer values. That doesn't make sense. Why would the input be a double if we're not expecting some fraction portion? Always over 30 only does the else. So making sure that you have at least one test input that's less than 30. If you have an input that's like 25, the output should be 5, but this one is not going to return 5. It's going to return 5 plus, minus, technically, something a little less than 5 in that case. So there's another incorrect solution. It's definitely wrong. Your test suite needs to have a test that's going to determine that that code is wrong. I won't go through all of these, but you get the idea that I have a lot of incorrect solutions. You'll only get to see these names when you submit. You'll see each one of my somewhat cryptic names. They're intentionally cryptic. I don't want to be like, I wrote code that only checks if the That's only correct if the values are over 30 or something. So always over 30. It's a little cryptic, but if you're most of the way there and you're thinking along the right lines, that's enough of a hint to get you across the line and go, oh, yeah, all my tests are over 30. So this is the idea. This is what's going on in AutoLab. You'll get those names. It'll say either passed or failed, an incorrect solution named always over 30. Like that'll be some of the sample output. And once you pass your solution, pass my correct solution, and fail all the incorrect solutions, then your test suite for that is at least good enough for AutoLab to let you move on. But that's what's happening in AutoLab. I have intentionally incorrect solutions that I'm running your tests against that. One implication of this is that your naming has to be exactly as it appears in the document, in the homework document, and you can't add new variables that you test. You can add new variables and functions and methods, whatever you want, but you can't call those, if you named it, you can't call it in your testing, because once I run your test suite against one of these solutions, if you're testing some variable that you created, it's not going to exist in my solutions. So you will get errors in AutoLab. If you ever get errors in AutoLab on all of my code, double check the homework document, double check your capitalization, make sure you didn't create a variable that also appears in your test suite. Never test something that you named. And check all those things if you see all those errors in AutoLab. We did the one example. I broke the code and showed you that it failed. I don't think I need to do, there's one thing I want to show. Because I get this question a lot after this lecture because I don't show it. So in my example, we had only 3 possible outputs, so I did 3 lists for the inputs of those outputs. That's not going to really work for your testing in the lecture tasks, though, because there are a lot of different outputs that it could be. To organize those, one thing, I'll go to this example. What I recommend is creating a map that maps the inputs to the outputs. So like I could rewrite, actually let me just do it here. So I could rewrite this as test cases of type map. I'm going to map doubles to strings. And then I would say like the input 60 should map to the string large. Oops, I missed my O. The input 59.9 should map to the string medium. And then for my loop, I'll loop over my test cases, loop over the keys and values like we saw last time. Oh my goodness, I can't type. And then make sure on this input, I get that output, and then I can update my hint text here. And then I can keep my test cases in one data structure and then iterate over the inputs and outputs and make sure that on every input I get the correct output. So that's how you can do it when you don't have only 3 possible outputs. All right, with that, have a good weekend, everybody. I'll see you Monday.